Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 246. Please turn to it, page number 246, and today's our lesson number 362. These problems that you see there on page number 246 are the exact same problems that appeared in the first edition of the revised GRE. We have already solved every single problem from here, every single math problem that is. If you're interested in watching the original solution to the problem, you will find the original solution on day number 158 and 159. We spent a great deal of time originally discussing this particular problem that we are about to do, which is part C, which deals with the parabola. It looks something like this. The equation that is given to us looks something like this. Part C is what we are dealing with. We are told that f of x equals 5 minus x plus 20 squared. Now listen very carefully. X plus 20 squared. Now listen very carefully, as I said before. This equation that you see there, you want to get to the stage, you want to get to the point where just by visual inspection, as I said already twice, two or three times, pay attention here, listen carefully. You want to get to the stage where just by visual inspection, just by looking at the equation like that, within 10 seconds, you should be able to tell, you want to be able to tell what has happened to this parabola. Has been shifted to the left, has it been shifted to the right, has it been shifted up or down, has it been flipped? All of those things are right here. This particular parabola has three things going with it. This part tells us, this plus 20 part tells us that this parabola has been shifted to the, now this is where I slow down always, this is where I always take a, this is where I always pause. This is where I always pause to remind you, this is the part, this is where the students make a mistake very often. You see x plus 20 and your gut feeling tells you, the inkling tells you, your intuition tells you that if it's x plus 20, obviously we're going to pick it up and shift it to the along the x-axis by 20 units to the right because it's plus 20. No, it's counterintuitive. When it is plus 20, that tells us it has been shifted to the left. Now there are two choices here you have at your disposal. One is to actually memorize this rule, which I don't like to do. I don't want you to go around memorizing things. I want you to understand the concept. The only way you're going to understand the concept, why is it being shifted to the left when we say it's plus 20? Why is it to the left then? Only way you're going to make the connection here and understand this concept is by investing appropriate amount of time, effort, energy. You have to make the investment. You have to learn the concept by watching these videos here. All of these videos deal with the concept of parabola. The concept of parabola essentially appears in this book on only 5 pages. There are only 5 pages where they discuss parabolas. These are the page numbers, 239, 240, 241, 243 and 245, and that's it. And these are the videos that I want you to watch if you want to get better at parabola. Day number 123, 124, 128, 129, 131, 133, and finally 135 and 154. This particular problem that we're dealing with actually deals with these 2 days. 345, where it says fat parabolas, that's what we're dealing with. Whatever we did on these 2 days, these are the same exact problem because from day number 251 everything was a duplication. So whatever we did on these 2 days is exactly what we're going to do here. I'm not going to repeat everything. I'm going to leave it up to you to watch these 2 videos. I'll leave it up to you to watch as many videos as you feel necessary until you feel that you're comfortable with the concept. So here we have 345, 342, 337 and 338. There is plenty of material here for you to get yourself acquainted with the concept. So this tells us it's been shifted to the left. Now let's start with something simple. Y is equal to x squared. This parabola, of course, we know is a standard parabola sitting at the origin. What happens if you have something like this? Y is equal to negative x squared. Well, we know from our past lessons that when you stick a negative in front of x squared, or whatever the quantity happens to be here under the thing here, When you stick a negative, that means the values of y's are going to be same as before. Here, before when x was 0, y was 0. Here also when x is 0, y is going to be 0. Before when x was positive 1 or negative 1, y was 1. Here also when x is positive 1 or negative 1, y is going to be 1, except it's got a negative in front of it. So it's going to be negative 1. All the values of the y's are going to be the exact same values for the given them for each corresponding value of x. The values of y's are going to be the same as before, except they're going to be all negative, which means it's been flipped. The parabola has been flipped. It's upside down. So this negative part tells us that it's been shifted, that it's flipped. This negative tells us it has been flipped. It's upside down. It's upside down. What does this 5 tell us? Well, let's find out, shall we? Let's find out again. So here we are, parabola x is equal to y squared. Y is equal to x squared rather. Y is equal to x squared. What happens if we have something like this? Y is equal to x squared plus 5. Now, all the values of y are going to be exact same values for each given value of x. The values of y are going to be exactly same as before, except you have to add 5 to everything. So all the values of y for each given value of x is going to be 5 more than before. It's going to be 5 more than before. So here's the original parabola. It's sitting at the origin. Now you simply pick up this parabola and shift it up by 5 units. It's the exact same parabola has been shifted up. This 5 tells us it's been shifted up. Let's make a note of it here. This 5 tells us that the parabola has been shifted up by 5 units. Now the reason why it is difficult to see all of this thing here is because they give this form, they give the equation of the parabola in a very nasty form, and they do it on purpose, of course. They want to be annoying. They give it to you in a nasty form because this is not the standard form of the parabola. Let's write our equation in the standard form down here, shall we? So this is our y. We are told that f of x equals this quantity here, which is the y. So y is equal to, we are told 5 minus x plus 20 squared. We're going to write that as negative x plus 20 squared plus 5. Now we can see this part that we just wrote here, deals with this 5 right here. It's been shifted upside down because it's negative. This negative tells us, this part that we just talked about, deals with this guy. It's been upside down. And this plus 20 tells us that it has been shifted to the left. Now all we have to do is plot this parabola. So all of this thing that we spent so far, the amount of time that we spent in the video so far, should have taken no more than 10-20 seconds. That's it. Just by visual inspection, we should have been able to tell all of those things. We should have been able to tell that there are 3 things going on here. The parabola has been shifted to the left. It has been shifted along the y-axis up by 5 units, and once we do that, then we have to flip it. Let's plot it, shall we? Now once we plot it, then we'll talk about where does it cut the x-axis and the y-axis, because those are the last things that are left here, because we have to look at the intercept, the places where the parabola is going to cut the x-axis and the y-axis. And we also have to talk about something called the line of symmetry. But in order for us to do all of those things, we have to see first how the parabola looks like. It's much easier to talk about all of those things if we have the visual aid, which is the shape of the parabola. Let's plot it, shall we? I need the room, so I'm going to erase all of that now. Oh, for Christ's sake. This is our y-axis, and you will see in a second why I put the y-axis way over there. Why do you suppose I put the y-axis way over there? Because it's been shifted to the left by 20 units. So I need to have a room 20 units here. So let's call this thing negative 20. Right here. This is where it's going to sit. And it's not going to be like this, it's going to be upside down. It's going to be upside down, and once it's upside down, see, once it is upside down, the equation of this parabola is y is equal to negative x plus 20 squared. Y is equal to negative x plus 20 squared. One more time, this plus 20 tells us that it has been shifted to the left by 20 units. This coordinates of this points are negative 20, 0. It is not sitting at the origin, it is sitting at negative 20 and 0. So that's this part, positive 20. This negative in the front tells us that it is upside down. We have not taken care of this 5 yet. So now we have to pick it up and shift it up by 5 units. That's all. Let's pick it up and shift it up by 5 units. Let's call it 5 here. 5 and 20. There is our parabola. I'm going to erase the other one because we don't need the other one. It's just in the way. Let's erase this and get rid of it. So this thing is negative 20, and this thing is the vertex. The vertex of this parabola is negative 20 and a positive 5. Negative 20 and a positive 5. Now let's talk about something called the line of symmetry. The line of symmetry is so called because it cuts the parabola into symmetric halves, which happens right here. Which happens right here, at the vertex. What's the equation of the line of symmetry? Well, the equation of the line of symmetry is, along this line, x is always 20. X equals to negative 20. This is our line of symmetry. Now the very last thing that is left for us to do is to locate the intercepts. Let's first talk about the x-intercept, the places where the parabola cuts the x-axis. It cuts the x-axis here, it cuts the x-axis there. Right here and right here. Here is our parabola. This point here, we have to locate the coordinates of these 2 points. Let's do that, shall we? We have to locate the coordinate of this point and that point. Well, we already know what the y coordinates are. The y coordinates of these points are 0 because it's sitting right at the x-axis. This is our x-axis. And the y coordinates are 0. So if the y coordinate of these 2 points are 0, if the y coordinate of this point is 0, we don't know what x coordinate is, but we know that y coordinate is 0. We don't know what x coordinate is, but the y coordinate is 0. So in order to find the x coordinate of this parabola, we just have to substitute the value of 0 for y in this equation and solve for x. Let's do that, shall we? We need the room, so we have to erase everything here. Again, give me 1 second here. I need a slight break for 10 seconds, 5 seconds. Let's erase everything. So like we said y is equal to 0 right here. This is our y. So y is, we can set it equal to 0, which equals to 5 minus x plus 20 squared. And we solve for x. Let's do that, shall we? So 0 equals, let's forget about this part now. So y is equal to 0. So 0 equals this amount, which tells us that x plus 20 squared, x plus 20 squared equals 5. Bring the x plus 20 on this side. When we take the square root of both sides, we find that x plus 20, take the square root of both sides, we find that x plus 20 equals positive or negative root 5. Which means x equals to positive or negative root 5 minus 20. Now listen, the part that I'm about to do right now, the part that I'm about to tell you, is only for those people who are very ambitious. If you really want to learn something, sink your teeth into it, so to speak. There is something that I want you to watch. Can you tell me what is the square root of 5? It sounds like a really silly question. So you would ask for those of you who are asking there yourself, why is this guy asking me what's the square root of root 5? Why do I have to memorize it? The calculator is right on the screen. Yes, you're right. The calculator is right on the screen. But if you reach for the calculator every few seconds, that's a dead giveaway that you're not going to get a good score. The people who reach for the calculator every few seconds are not the ones who get very good score. The person who gets a good score in the math on the GRE is the one that you will see hardly ever reaching for the calculator. Maybe in the entire exam they will reach for the calculator perhaps 2 or 3 times. That's it. There are 2 or 3 questions that are really nasty where you need calculator. These things you have to know. What I want you to do is watch. I would like you to watch day number 350. Day 350. And what I'm talking about appears towards the end of this video. Watch day number 350, and there you will learn what square root of 5 is. There you will learn the square root of 5 is approximately 2.2. And if you watch this entire video, you will know why I'm making such a big fuss about it. So anyways, this is 2.2. So x equals negative 20 plus or minus 2.2. Now we can no longer say x equals to it because this is approximately. So we have to say x approximately equals to, which means x is approximately negative 20 minus 2.2, which means it is 22.2, or x is equal to approximately equal to negative 20 plus 2.2. Negative 20 plus a 2.2. Negative 20 plus 2 would have been negative 18, so it's going to be negative 17.8, approximately negative 17.8. There we go. We found the intercept. This guy here is this guy. These are negative. I forgot to put a negative in front of it. This is a negative 22.2 and this is negative 17.8. Negative 22.2 and negative 17.8. This guy that we were trying to figure out before is negative 22.2. Negative 22.2 and y is 0. This one is negative 17.8 and y is 0. What else is left? Is there anything else left for us to figure out? The answer is yes. We have figured out the x-intercept. We know now where the parabola cuts the x-axis. It cuts the x-axis here and here. But we haven't located the point where it cuts the y-axis. The place where it cuts the y-axis is called the Y-intercept, and that's where x-coordinate is 0. The x-coordinate of that point, the x-coordinate of this point is 0. We know that. But what is the y-coordinate? We have to find that. We have to find the y-coordinate of that point, but we know that x is equal to 0. And that finding the y-coordinate of that point is actually very straightforward, very simple thing, because all we have to do is substitute x equal to 0 in this equation. Let's do this, shall we? Again, I'll give you a break. I'll get out of your way in case you need to. Just give me 1 second. So like I said, all we have to do is plug in x equal to 0 to figure out the y-coordinate, and that will give us the y-intercept, the place where the parabola cuts the y-axis. X is equal to 0 over there. Let's do our equation here. So here's our equation of the parabola. We just substitute x equal to 0. So y is equal to 5 minus, or the way we had written it, was this. Y equals x plus 20, negative x plus 20 squared plus 5. Which means y is equal to negative 0 plus 20 squared plus 5, because x is equal to 0. Remember, right here. 20 squared is 400, so we get negative 400 plus a 5, which is negative 395. Voila. Negative 395. So now we know that the coordinate of that point is 0 and negative 395. Let's make a note here, down here. I want to write it here in the event that that thing is out of the screen. The y-intercept, the place where it cuts the y-axis, y-intercept, we just found is 0 and negative 395. That's it, we're done. That's our parabola. Oh boy. But of course in the exam they're not going to ask you everything, obviously. There is a lot going on here. They're just going to ask you one tiny aspect of it. And you have to be able to figure out whatever it is that they're asking here, whatever it is that they're asking you there, in a reasonable amount of time, within a minute or so, maybe 2 minutes at the very most, if you're doing it slowly. No more than that. Maybe they will ask you for the Y-intercept, maybe they will ask you for the X-intercept, maybe they will ask you for the coordinates of the vertex, maybe they will ask you the equation of the line of symmetry. Or maybe they will simply give you the 5 pictures and they will ask you to identify which one of the 5 pictures corresponds to the given equation. If that's the question, that can be done in 10 seconds. You just look at the equation, it tells you, you say to yourself, it's been shifted left by 20 units, it's upside down, and it is shifted up by 5 units. And you look at the one parabola that corresponds to all of this thing. This is the one. This is the one that's been shifted left by 20 units, it's been lifted up by 5 units, and it's upside down, it's flipped. That's the one. I'll see you tomorrow, okay? Bye now.